Hello and welcome back to the whitchermath channel on YouTube. Today we're going to practice transformations, just like our mild-mannered janitor would jump into a file cabinet and turn into crime-fighting superhero Hong Kong Phooey. We're going to do something with these here shapes. So I have two problems. In the first one, you're going to describe possible transformations that could have happened to get you from the red one, A, to B, the green one. And the second problem is simply starting here and doing these three transformations and then drawing in the finishing shape. Now's a good time to pause the video and get your paper set up and do this. I'll see you in a minute. Okay, we're back. I hope you paused because obviously that was not a minute. And here we go. First, disclaimer, right? There's lots of different ways to get from A to B. I'm going to show you one way, okay? You compare your way and see if we land in the same place. The key is we're working on the vocabulary and using precise academic language. So I made a little foamy piece there so I can kind of follow this around. So here's one thing I could do. And if your goal is always just to have the fewest steps and make it as easy as possible, then you might have gotten the same thing I did. Okay, here we go. I'm going over here and then down here. I just need to describe that, okay? So the first thing I need is a vertex. And it doesn't matter which one you pick, there are 4 of them, right? And they're all going to do the same thing because the whole shape is moving. So if I start by moving over here, my vertex goes over there. And then the rest of the shape is oriented around that, okay? But the bottom line is that vertex went that far. It went 1, 2, 3, 4, 5, 6 to the right. So we say translate x plus 6. And then that same vertex is right here, which that is y minus, because it goes down, 1, 2, 3, 4. So here is a great way to write that. Translate x plus 6, comma, y minus 4. If you write it like an ordered pair, then, well, for one thing, it's short and concise. But for another thing, if we take any vertex on there, it'll give us the new coordinates, which is super handy. For example, the old ones here of mine were 0 and 2. So if I translate 0 plus 6 and 2 minus 4, that gives me the new coordinates. I don't even have to try to count this and figure it out. Okay, 0 plus 6 is 6, and 2 minus 4 is negative 2. Right? And we could check that from the origin, 1, 2, 3, 4, 5, 6, and negative 2. So by writing it in this way, you give yourself a way to write the new coordinates of any new vertex. I think that's worth highlighting. It's a very useful way to write it. Okay, let's go to the next one. Yep, I even made a little foamy guy right there. Okay, let's modify him a little bit. There we go, little smiley guy. Okay, he's happy, he's moving. He's excited about new things and embraces change. What a guy. Okay, we're gonna translate. First, we need a what? Right. Vertex. Okay. We're gonna go left 6 and up 1. 1, 2, 3, 4, 5, 6 to the left, up 1. That corresponding vertex is in that spot now. Okay, that just means the same vertex at the same place on the same shape. Bam, he's right there. So we check that off the list. And maybe I'm just going to kind of sketch it in there in case a windstorm comes and blows a little happy guy away. Okay, so we're there. Rotate 90 degrees clockwise around -1 and 2. Well, first let's find -1 and 2, which is right there. And rotating clockwise means this. Same direction as a clock. Lay down, little buddy. Go to sleep. Very nice. Okay, just like that. That's the advantage of having a little thing in your hand that you can manipulate here, because you can see exactly where to draw the new shape. Okay, so I'm just going to tip him over. So here was step 1. Here's step 2. And finally, step 3, we want to reflect over y equals 2. Very simple. Since this is the y-axis, and this is 2 on the y-axis, I'm going to make that the line of reflection and flip him over that line. Okay, so it means this. Ba-na-na-na-na-na-na, sha-na-na-na-na-na-na. Boom! Just like that. Okay, here's a slow motion replay. Ba-na-na-na-na-na, sha-na-na-na-na. Wow, this technology is crazy. So here we go. My paper ends up looking like a mess, but I got little happy guy into his new house right there. And we're done. Say goodbye to happy guy and stay tuned for more transformation practice later. Later.